A program's code rarely executes in a linear fashion. We usually have code that only runs if a specific condition is met. That's what we call conditional logic. The programs we've written so far were quite simple. We started executing the first line and continued to the next one, then the next one, and so on until we reached the last statement. Writing programs this way wouldn't make too much sense. We need to ask questions and make decisions. Even the most straightforward program will probably need some conditional code. In real life, we have to answer questions and make decisions based on the answers to these questions. Is the traffic light green? If yes, go. Seeing red? You better stop. Is there enough money in your bank account to cover that overseas trip? If yes, go ahead and book your travel. Similarly, in our programs, we need to have code that only runs if specific conditions are true. That's what we call conditional code. In Python, you write conditional code using the following syntax: the keyword if, followed by a conditional statement and a colon. Then, the code you want to execute when that condition evaluates to true. If the condition is false, we run the code that comes after the else keyword. The condition isn't a word or a phrase, but rather something in the form if A equals B, or if money is less than the balance. The expression that follows the if keyword must break down as being either true or false. Let's continue with an actual example. Open up Visual Studio Code and create a new Python source file called conditionalcode.py. Type the following code in the editor. First, I declare two variables. Balance represents the bank balance, and money is the cash we want to withdraw. Then we have a conditional statement, if balance is greater than money. The colon character marks the end of the if statement. The statements following the conditional statement are 4 spaces in from the if. And I need to also indent the code that follows the else statement. Now that's something new. To understand why did we indent these code lines, we need to introduce the concept of code blocks. A code block is a section of code that gets executed together. Python uses indentation to break down code into blocks. Other programming languages use curly brackets for blocks, but the creator of the Python language decided to use indentation instead. Fewer special characters mean less typing and less cognitive load for humans. However, it may take some time to get used to it if you already used C-based languages like Java, C# or Swift, to name a few. Now, if I unindent the statements from the if block, I'll get a syntax error. That's because the code that follows a conditional statement needs to belong to a new block. The conditional if statement is at the level of 0 indents. The block following the conditional statement must have a higher indentation level. That's how Python knows those statements belong to a block, and that block of code is associated with the if statement. So let's fix our indentation error by restoring the original indentation. All the statements that belong to a block need to be at the same level of indentation. If I indent any of the statements differently, you'll notice that I'll get syntax errors. Now, if I try to run the file, we get an indentation error, unexpected indent for this line number 5. So be careful to use proper indentation to delimit your blocks. Python relies on the indentation level to figure out which statements belong together. We'll use blocks a lot as we proceed throughout this course. Now that we clarified what code blocks are for, we can dig deeper into conditional code. As we've seen, a conditional statement must evaluate to a Boolean. In the previous example, we checked if the number is bigger than the other one, and I used the greater than sign to do that. There are also other operators that can be used in conditional statements. Besides greater than, we can check if the value on the left side is greater than or equal, less than or equal to the value on the right. It is also ubiquitous to check for equality and inequality using the equals and not equals operators. Here's the list of the comparison operators you can use in conditional statements. These comparison operators work with numbers, strings, and also other data types that can be compared with each other. Now, let's take a closer look at our previous example. What happens if the amount we want to withdraw matches the balance? It says insufficient funds. So we couldn't retrieve the money because the condition balance is greater than money evaluates to false. Thus, the else statement code block will execute that prints insufficient funds. We can fix the issue easily by replacing the greater than with the greater than or equal operator. The rest of the code remains unchanged. Now, this small change will let us withdraw all the money from our bank account. After this transaction, the balance turns 0. Make sure you don't add a space between the greater than and the equal sign. That extra white space will cause a syntax error. So let's undo our change. The greater than or equal, less than or equal, equals, and not equals comparison operators must be written together without spaces between them. Another common mistake is using a single equal sign in conditional statements. Let me show you what I mean. First, I create the isTrue variable and set it to false. If isTrue is true, then print true. Else, print false. Can you spot the issue? The isTrue equals true in the code snippet doesn't compare values. It is an assignment, so you shouldn't use it as a condition. In many other programming languages, assigning a value to a variable evaluates to true, and the if block gets executed. Python prevents us from making this mistake. Trying to execute this code will trigger a syntax error. Alright, so let's recap. Follow these rules when writing conditional code. Keep the less than or equal, greater than or equal, equals, not equals comparison operators together. Use the equality operator to check if two values are equal. Alright, our example so far involved both the if and the else statements. However, that's not mandatory. You can use the if statement by itself. I create the isRaining variable and initialize it to true. If isRaining is true, we print take your umbrella. Bear in mind that you cannot use else without the preceding if statement. However, nothing stops us from using multiple if statements in a row. The code prints the number is even, the number is greater than 10, and a dozen. As you may have noticed, I used a new operator. The percentage sign is the modulo operator, which calculates the remainder of the division. If modulo returns 0, there is no remainder, so the number is even. A non-zero remainder means that the number is odd. Since 12 divided by 2 is 6 and the remainder is 0, 12 is an even number. Now let's change the value of the number variable to 11. It prints the number is greater than 10. Only one of the if statements evaluates to true. Indeed, 11 is greater than 10, but it's neither even nor equal to 12. Next, we talk about nested conditional statements, and I'll show you how to make additional decisions. As you start using conditions in your programs, you will notice that a pair of if-else statements is rarely enough. Many times, you will need 3 or more conditions. One possibility is to use multiple if statements as we did in this example. Now, there are cases when we need to check multiple conditions and execute the first one that evaluates to true. Take a look at the simplified flowchart of a traffic light. We could use multiple if statements to make it work in Python. If we used the if statements like that, Python evaluates each conditional statement. Is the light green? Yes, so print go. Is the light yellow? No, evaluate next if. Is the light red? No, next one. Is it flashing? No. The else statement's code won't run as one of the if statements was true. But we know that the traffic light can only be in one of the states at a time. So why evaluate the other conditions if we know that the light can only be either green or red or yellow? Performing the additional checks is unnecessary. We're just wasting resources and computing time. The solution comes in the form of the elif keyword, which stands for else if. Let's rewrite our code using elif statements. An elif statement can only appear after an if statement. The if statement gets evaluated first. If it's true, the elif and else statements are not evaluated. The first conditional statement, traffic light equals green, is true. Therefore, the 3 consecutive elif and the else statements are skipped. Now, what happens if we assign the value red to the traffic light variable? The condition in the if statement is false, so the first elif gets evaluated next. The expression traffic light equals yellow also evaluates to false. So we process the next elif. Traffic light equals red is true. So Python runs the associated block of code and prints stop. The penultimate elif and the else statements are skipped. As you can see, it printed stop. If you change the traffic light to some invalid value like blue, none of the if or elif statements resolve to true. The code block belonging to the else statement gets executed, which prints invalid state. There may be situations when you want to check for another condition after a condition evaluates to true. In such cases, you can nest an if statement inside another if statement. You can also add else or elif statements to a nested if structure. Here's an example. A word of advice: avoid deeply nested code. Normally, you shouldn't go beyond 2 levels of nesting. Otherwise, your code becomes overly complex and hard to understand. In programming, deep nesting is a problem known as the arrow anti-pattern. The name comes from the shape of nested if statements. Boolean operators allow us to combine multiple conditional expressions without relying on nested if statements. So hang in there, we talk about Boolean operators next. Let's examine the code snippet with the nested if statements. I'm going to delete our arrow anti-pattern example and let's scroll up. All right. The first if statement checks if the traffic light is red. The nested if checks if is blinking is true. So basically we're asking if the traffic light is red and it is blinking at the same time. What if we could express both conditions at once? Actually, we can do that. The statement above is completely valid Python code. The AND word is one of the 3 Boolean operators, also known as logical operators. The AND operator takes 2 expressions, and it returns true only if both expressions are true. Otherwise, it evaluates to false. Now I'm going to remove this line, and let's try out something else. I create a Boolean variable called success, and let's initialize it to true. And here's the second variable called result code. Next, I'm going to check if success is true and result code equals 200. If both success equals true and result code is 200, I print success. Else, print failure. If you run this code, it prints success. Both expressions in the if statement resolve to true. So we have true and true, which evaluates to true. Now assign the value false to the success variable. And let's execute the code again. This time, the condition in the if statement becomes false equals true and true. Now, false equals true is false. So the condition boils down to false and true. The result is false because the AND logical operator returns false if any of the expressions are false. The OR logical operator takes two expressions too. It returns true only if any of the expressions are true. Now, let's type the following code in your Visual Studio Code editor. I'm gonna close this one and let's scroll it up. I create a variable called first name. And let's assign the string literal Alan to it. And last name. Make it Ripley. And next, we check for the length of the first name and the last name. In the if statement, I used the logical OR operator to check if both first name and last name have a valid length. If either is empty, we prompt the user to enter her name. Otherwise, the program greets the user. And I'll be using an F string here, which says hi, and the value of first name and last name. The program will print, "Hi, Alan Ripley." Let's try it out. Awesome. Now let's follow through what's happening in the if statement. Len first name equals 0 resolves to false, since the text stored in first name, Alan, is 5 characters long. Len last name equals 0 also evaluates to false. Ripley has 6 characters. So we have false or false, which evaluates to false. So the else statement's code block gets executed. The third logical operator is not. The not operator takes a single expression, and you can use it to negate a Boolean expression. In other words, placing not in front of a Boolean expression reverses its meaning. Let's go back to VS Code and type the following. Here, we check if a user is not an administrator. Not admin user resolves to not false, which is true. Thus, the program runs the code block associated with the if statement. Let's run it. Indeed, we've got permission denied in the terminal. Now you know how to write conditional code in Python. To solidify the concepts, play around with the exercise code and see what happens if you make some changes.